Hello, podcast listeners. Welcome to another great episode of Podcasts with Gautam and Jin. Thank you for joining us today. My name is Jin Vanstee, and with me is my co-host Gautam Siwach. And today we're very excited to have Naeem Altaf. Naeem is an IBM Distinguished Engineer and CTO of Space Technology in the IBM Hybrid Cloud business. He's working to expand IBM's presence in the space technology sector. He also serves as a chief solution architect, leading innovation group to build first-of-a-kind proof of concepts and technology prototypes for strategic application expansion into industry verticals on IBM Hybrid Cloud Platforms. Naeem, welcome to our podcast.
Thank you so much, Jane and Gautam, for having me.
All right, Naeem, that's a super cool job title. Can you please tell us what is Space Tech Initiative?
Sure, thank you. Jane, so space tech means is the systems and applications which we are building, designing, manufacturing for its application in space. So for example, the stuff we are sending for Earth observation as satellites, these probes which are going further away to examine the planets, and then we are for the space travel. So all these technologies which are used for different kinds of explorations, that's where the space tech categories falls into. And one easy example for people to relate to is the GPS systems and the Earth observation. So you have all these weather satellites, which shows you these amazing graphics of when the hurricanes are coming, or you see these different weather patterns over the globe. These are all the technologies which we refer to as space tech.
Awesome. And what are some examples of the challenges that you face in extraterrestrial and space-related problems?
Sure, that's a good question. So you probably have heard this very famous line that space is hard or space is not easy. So yes, there are lots of challenges. The biggest challenge which we are hearing these days is about the space debris. So you have a lot of debris in the low Earth orbit because of the activities happening for past 50 years. Satellites are being put in, the satellites disintegrate. There have been like 2 or 3 collisions around the satellites, which created more debris into the orbit. So that is a serious, real threat. And we saw in last 12 months that the space station, which is in the low Earth orbit, had to maneuver like 3 to 4 times. And that is a very, very expensive operation because of the limitations with the fuel and stuff. So there are challenges, what's in the low Earth orbit. There are challenges with the communication. We don't have as the high bandwidth or the throughput in terms of network communication between the ground stations and these probes in the low Earth orbit. If we are in the low Earth orbit, you only have like a pass of around 10 to 12 minutes. So you have to uplink or downlink within that time frame until you hit the next ground station. Then there are challenges about the hardware. So it's not like you can just take your PC motherboard and just put that up in the orbit. It has to be radiation hardened. There's a very high radiation. So if you take a regular compute, it will burn the chip and the motherboard and cause lots of issues. That's why you see these specialized architecture. You see they are enclosed in these radiation hardened enclosures where your compute is put in. So with that comes a complexity of, if you don't have off the shelf kind of your compute and you have these specialized processors, then you have to go and recompile all your code for that specialized. So that adds more to software development. The other ones are the security. And there's lots of events happening in the world these days, and there are lots of challenges because we are relying more and more on these satellites for many different purposes. The most obvious one is the GPS, which almost everyone uses it every day. So security is a huge way. The communications are being hijacked, or and then if we talk about the space travel, so the health of astronaut, that's a huge concern, and we have lots of studies done on space stations. And the space station is a lab for us, right, where we do different kinds of things in the microgravity environment. So whenever the astronauts have to do a spacewalk, it's quite risky, and then there is lots of vitals which has to be checked continuously as they are doing the inspection of space station and stuff like that. So these are a few of the areas which are huge challenges, and that's what we are looking to see how we can resolve using the technologies we have today.
Great. And what is the future of technology in Space Tech program from the technology side of the house?
Sure. So, like I mentioned in the previous question, all these different challenges we have. So with those challenges, there's an opportunity, and that's where we are looking at the space tech. What can we do to try to resolve all of these concerns? So first thing, which technology, or actually the design and the build of rockets which have solved for us is the launch. That's the first step. In 20 years ago, launching a system was extremely expensive, almost like $24,000 per pound, and it has reduced significantly with all these SpaceX launches happening. And that's because they can recover their rockets, right, and they can reuse them. That all brings the cost down. So that's the first thing. It's much easier now to put stuff in the orbit. The next thing is the edge computing. So what we are trying to look into is how can we use the off-the-shelf compute, and that's where the companies we are working with, they are coming up with is radiation-hardened boxes which they can stick outside the space station, and we can drop our regular compute and still be able to do a computation. So that will ease a lot, because now I can just use off-the-shelf compute, and you can use your whatever development you were doing. The next thing is the edge computing in space, and this is with IBM's whole stories about the hybrid computing. So we are extending the hybrid compute spectrum from the terrestrial networks to in the space. We have done edge computing in space for DNA sequencing on space station, and that was our edge computing, basically extending the spectrum of hybrid compute. We just recently launched IBM's first space mission satellite, a CubeSat, where we can perform the computation on the satellite for different, working with different sensors to demonstrate edge computing. The next big thing happening will be the laser-based communication, because right now most of the stuff is through radio communications. Like I mentioned, you have few minutes of pass over the ground station, and the birds or the spacecraft which are in continuous connection with the ground are in the geostationary orbit. So it's an example is your dish network, or these different kinds of for TV satellites used at home. They communicate with geostationary or satellites, which means that the satellite is orbiting at the same speed as the Earth is rotating. So you don't have to keep on going outside and moving your dish. So many satellites beam data up to the geostationary, and from there it beams down to the ground stations. So with these laser communication, we will have a much higher bandwidth and throughput, and in a pass of 10 minutes, we'll be able to do a lot more work than what we can do today. Other interesting areas are you will hear about in-orbit servicing. So these satellites which we put up in the orbit, these are like $100, $200, $300+ million satellites, and they have a life of 10 to 15 years. But what if we can extend that life? How can we send another spacecraft which can talk with it and service it? Maybe it ran out of fuel or something. It can go and fix it. There is a huge discussion and is about that putting data centers in space. Yeah, now that sounds a little crazy, but that is actually being discussed, and there are many startups. Think about all these activities happening in the low Earth orbit, and mostly it's towards the Earth observation. So we are watching the supply chain, we are watching the climate, or the patterns, the weather patterns. There's so much stuff happening from the low Earth orbit that all of that data, which is in gigabytes or terabytes being produced by this imagery, it has to come down to the ground and then processed, and that takes a lot of time. How about if we have in the orbit, we have a set of servers and some data can be examined over there before it's sent to the ground. So there will be a whole new the things which we have learned on the ground. How do we build data centers, especially when it comes to the edge? How will they communicate? How resilient they will be? So all those concepts will be applied over here, and of course, it's much more complicated in the orbit. And last but not least, there will be what's really fueling all of this space sector is where the public and private sector is coming together for innovation. Before it used to be, the major space agencies and maybe the government agencies working together, but now you have seen what SpaceX has done. They have really changed the game, right? Where the private sector and public, they're all coming together and to move this innovation much, much faster than it was happening before. So thank you so much, Gautam and Jin. And everyone, please don't forget to log in on Monday to see the NASA SLS going to the moon. That's a huge deal happening on Monday morning at 8:30, I think, Eastern time. Thank you.
Awesome.
To think of things beyond known and to explore the unknown. Thank you, Naeem, for the interesting space initiative and using technology to do so. Audiences who have new ideas and requirements around the space, please feel free to reach out and connect with Naeem. Today we had Space Tech Initiative CTO from IBM, Naeem Altaf, and you're listening to the podcast with Gautam Siwach and Jin Vanstee. Keep listening, please share, and thank you for your continued support.